These are the 4.2 notes for trigonometry. We're going to talk more today about right triangles. So remember, you have SOHCAHTOA, which means that sine is equal to O over H, cosine is equal to A over H, and tangent is equal to O over A. So instead of actually having a triangle today, they're actually going to give us two of our answers, and then we're needing to find whatever other answers they want us to get. So sine of theta is 1/2. So I'm going to label O and H right here. Then I know cosine is A over H, so I'm going to label A and H. And if you notice, we have all three of our sides of a triangle. O is 1, 2 is H, A is radical 3. So then once I have all three sides, I can go ahead and write the rest of my answers. Tangent, which would be O over A, would be 1 over radical 3. We'll need to rationalize the denominator, multiply by the denominator over itself. The radical 3 times the radical 3 would get us radical 9, which then can be square rooted to regular 3. And in the numerator, 1 times radical 3 is radical 3. All right, so for cosecant is H over O, or the reciprocal of sine. So I'm just going to take the sine 1/2 and flip it to 2 over 1, and then simplify that out to 2. Secant, H over A, or the reciprocal of cosine, would be 2 over radical 3. We'll need to rationalize the denominator again there. Same thing, radical 3 is 3. And up at the top, I have 2 radical 3. So because the 2 is not inside a square root, I don't actually want to multiply the 2 and the 3 together. The 2 stays on the outside, the 3 stays on the inside. And cotangent, A over O, which would be square root of 3 over 1, which can just simplify to square root of 3. All right, so for example number 2, what about if we have some negatives? This is the first time we are dealing with negatives when we have sine, cosine, and tangent. So the thing about the negatives is the hypotenuse can never be negative. Hypotenuse can never be negative. The adjacent and the opposite can both be negatives, but never the hypotenuse. So when we look at this first one, sine of theta equals 4/5, I don't see any negatives. I'm just going to label O and H. When I get to the cosine, I have a negative 3/5. And if you move a negative, you can either move it to the top or to the bottom. It means the same thing. But because cosine is A over H, I know that I cannot move it to the denominator because the denominator is H, and hypotenuse can never be negative. So I'm going to move this negative up to the 3. So that way the adjacent side is negative 3, the hypotenuse is 5, and the opposite side is 4. Once I know all three sides of my triangle, I'm just going to answer the question that they asked. They are only asking for tangent on this one. Opposite over adjacent. There we go. All right, for problem number 3, find the exact value of sine, secant, and cotangent. So kind of some random ones. We'll first start by labeling what we have. Cosine, A over H. Let's move the negative. It can't go to the H, so it will have to go to the A. At this point, people always ask, does it always go to the top? Not necessarily. All right, so tangent. Tangent is O over A. So this is a little strange because you don't really know where the negative goes because O and A, either of those could be negative. So I'm going to look back at what I already know. I already know that A is negative 6. So I'm going to move my negative onto the 6 so that way the two A's match. That will leave the square root of 13 as a positive. So now I know all three of my sides of the triangle. And we're going to find the three values that they asked. Sine, secant, which I'll abbreviate to SEC, and cotangent, which abbreviates to COT. Sine is opposite over hypotenuse. No need to rationalize the denominator. The denominator is a regular 7, so we're good there. Secant is cosine flipped, or h over a, so 7 over a negative 6. Again, nothing to worry about there. That's already simplified. And then the last one, cotangent, a over o, or flip the tangent value. So we get that. And we will need to fix this one up. No square roots allowed in the denominator for your final answers. Multiply by the denominator. If you want to type into your calculator 13 times 13 and then square root that number, you can. But the thing about the 13 and the 13 and any numbers you use, it's always going to end up being just a regular version of that number. And then over here, we'll have negative 6 radical 13. Problem number 4. This time they're asking for just tangent and secant. Sine O over H. Figure out where the negative goes. It'll have to move to the top with the O. It can't be on the H. And then A over H for cosine. Same thing. We'll move it away from the H. Put it on the A. And then we'll find our answers for tangent and secant. All right, tangent is O over A. And this is just kind of a lesson in simplifying some things. If you have the exact same thing at the top and the bottom, like the square root of 5 and the square root of 5, and the negative, those can cancel out, which means you're left with the 2, but the 2 is in the denominator, so you'll have to put a 1 as a placeholder up at the top, making your final answer 1/2. Secant is H over A, so 5 over negative 2 square root 5. I can't cancel the 5s because 1 is not a square root. I can't cancel any negatives there. So I still have an issue because I can't leave the square root of 5 in the denominator. So what I'll do is I'll rationalize the denominator, multiplying by the square root of 5, kind of ignoring that negative 2 for right now. And then what happens here is this square root of 5 and that square root of 5 come together to make square root of 25, which then when I square root it gets me a regular 5. So now what I have, at the top I have a 5, radical 5, and in the denominator I have negative 2 and a regular 5, that 5 right there. So now what you can do is you can cross cancel the 5 and the 5 out, which leaves you a final answer of square root of 5 over negative 2. If you hadn't thought to cancel the 5s, another option that you could have done, you would have had 5 radical 5 over, and let's say you multiplied those two numbers together to get negative 10. Then you would have looked at this part right here and just reduced that as a fraction to make 1 over negative 2, negative 1/2, square root of 5. Then you wouldn't need that 1, and you would still get to the same place.